Hi, in this video, we are going to discuss about salt hydrolysis. Here are the learning outcomes for these lessons. At the end of this lesson, students should be able to explain salt hydrolysis and then classify the salt into neutral, acidic, or basic solution. How to form a salt? Salt can be formed by the neutralization reaction between acid and base. From this reaction, it will form salt and water. Salt are ionic compounds produced by the neutralization of acid and bases. Many salts dissolve in water to produce a neutral solutions. However, some of the salt dissolve in water to give an acidic or basic solution. What is salt hydrolysis? Salt hydrolysis can be defined as the reaction of the cation or the anion of the salt with water to produce either acidic or basic solutions. Salt can be classified as a neutral, acidic, and basic in aqueous solution as they undergo hydrolysis. There are four ways of making salts from acids and bases. They are involving the reaction between strong acid and strong base, the reaction between strong acid and the weak base, reaction between weak acid and strong base, and the reaction between weak acid and the weak base. How can we determine if a salt is a neutral, acidic, or basic? Now, let's discuss on how to classify the salt into neutral, acidic, or basic solution through salt hydrolysis reaction. Let's take a look for the first reaction that involves strong acid and strong base. For a reaction between strong acid and a strong base, for example, the reaction between hydrogen chloride and the sodium hydroxide will produce sodium chloride salt and water. The dissociation of the salt presence in water can be written as shown in the equation. The sodium chloride salt solution is completely ionized to form sodium plus ions and the chloride ions. Sodium plus ions is a weak conjugate acid that form from the strong base of sodium hydroxide, while the chloride ion is the weak conjugate base that form from the strong acid of hydrogen chloride. In hydrolysis, only strong conjugate will be selected. In this reaction, both of the cation and anion in the salt will do not hydrolyze. This is because sodium plus ions is the weak conjugate. Therefore, it will do not selected in the hydrolysis. The Cl- ion is also a weak conjugate. Therefore, it is also not selected for hydrolysis. Since both cation and the anion is not hydrolyzed, therefore no production of extra hydronium ion or the hydroxide ion from the hydrolysis. Thus, the salt has a pH that equals to 7. Therefore, we can classify the salt as a neutral salt. Now, let's discuss the salt of strong acid and the weak base. Here is an example of a strong acid and a weak base reaction. It is the hydrogen chloride solution, which is a strong acid, react with a weak base of ammonia solution to produce the salt of ammonium chloride. The dissociation of the salt present in water can be written as shown in the equation. The salt of NH4Cl will completely dissociate to form the ammonium ion and the chloride ion. The ammonium ion is a strong conjugate acid that forms from the weak base of ammonia, while the chloride ion is the weak conjugate base that forms from the strong acid of hydrogen chloride. In hydrolysis, we know that only strong conjugate that will be selected. Therefore, only cation in this salt produced undergoes hydrolysis. It is involving ammonium ions. Ammonium ions will hydrolyze with water to form ammonia and hydronium ions. From the hydrolysis of ammonium ion with water, we can identify the presence of H3O plus ions. Thus, this solution is acidic solution. Therefore, the pH of this solution must be less than 7, and they are classified as acidic salts. Let's discuss the salt of weak acid and the strong base. This is an example of the reaction between weak acid and a strong base. When a weak acid of ethanoic acid reacts with a strong base of sodium hydroxide, it will produce the salt of sodium ethanoate with water. The dissociation of the salt presence in water can be written as shown in the equation. The sodium ethanoate salt solution is completely ionized to form sodium plus ions and the ethanoate ion. The sodium plus ion is a weak conjugate acid that forms from the strong base of the sodium hydroxide, while the ethanoate ion is a strong conjugate base that forms from the weak acid of ethanoic acid. We know that in hydrolysis, only strong conjugate will be selected. Therefore, only the anion in the salt produced will undergo hydrolysis. The anion involving the ethanoate ions that hydrolyze with water to produce ethanoic acid and hydroxide ions. From the hydrolysis reaction, we can identify the presence of hydroxide ion. Therefore, the salt must be a basic solution. It has a pH more than 7, thus we can classify this kind of salt as a basic salt. Now, let's discuss the salt of the weak acid and the weak base. The reaction between weak acid and the weak base can be written as in the reaction between acetic acid and the ammonia. Acetic acid is the weak acid. Ammonia is a weak base. When both of these acid and base react, it will form salt of ammonium ethanoate. The dissociation of the salt presence in water can be written as shown in the equation. The salt solution is completely ionized to form ammonium ion and ethanoate ions. The ammonium ion is a strong conjugate acid that forms from the weak base of ammonia, while the ethanoate ions is a strong conjugate base that forms from the weak acid of ethanoic acid. In hydrolysis, only strong conjugate will be selected. In this reaction, both of the cation and the anion is a strong conjugate, thus both can be hydrolyzed. The pH of the salt solution depends on the relative value of the Ka for the cation and Kb for the anion. In this salt solution, Ka of ammonium ions and Kb for ethanoate ion are about the same, that is 5.6 exponent negative 10. The salt solution has a pH that equals to 7. Thus, the salt can be classified as a neutral salt. But remember, the pH of the salt solution of the weak acid and the weak base reaction depends on the relative value of the Ka for the cation and Kb for the anions. The higher the value of Ka or Kb will determine whether the salt solution is a neutral, acidic, or basic solution. As a conclusion, the salt produced from the weak acid and the weak base reaction can be any neutral, acidic, or basic salt solution. Now, let's try an exercise questions. Predict whether the following salt solution is a neutral, acidic, or basic solution. First, sodium bromide, ammonium nitrate, and sodium cyanide. Click pause button if you need more time to preview the answers. Now, let's check the answer. Sodium bromide is a neutral salt. Ammonium nitrate is an acidic salt. Sodium cyanide is a basic salt. Before we end our lessons today, here are some tips to remember. The strong acid will produce a weak conjugate base. The strong base will produce a weak conjugate acid. Weak acid will produce a strong conjugate base, and the weak base will produce a strong conjugate acid. You need to remember that only strong conjugate will be selected for hydrolysis with water. When a hydrolysis forms extra H3O plus ions, thus the salt is an acidic salt with pH less than 7. When a hydrolysis forms extra OH minus ions, thus the salt is classified as a basic salt with pH more than 7. When the salt is do not hydrolyze, thus it is classified as a neutral salt with pH equals to 7. So, this is the end of our lessons today. We'll see you next time. Bye!